This week in Design 330, we're going to be looking at another part of plumbing. It's actually not usually listed as plumbing, but it is water related. It's fire riser design, and it's its own little section usually, but in our courses we teach it along with the plumbing. And our goal is to create a fire riser assembly for use in a facility design. Fire is obviously one of the main safety and health aspects of design. Fire suppression or fire prevention, and every facility design takes fire into account. So it's very applicable for us to take at least a brief review at this. I do have a lot of background in it because the valves that I used to design are part of a fire suppression system. And so that's where we're going to focus ourselves this week. And just to learn a little bit about it, we're going to research our fire riser requirements and what a fire riser is. You'll get to model individual components, and you can use Revit, AutoCAD, or Inventor. Those are all able to go back into Revit to create a Revit family later on. So we'll do that. And then because you'll have many of the components already drawn, you'll be able to create some tabulated component drawings just to tie what we did in the first 8 weeks closer into what we do in the last 8 weeks of this class. So let's take a look and see what a fire riser is. So fire suppression uses sprinklers in the roof to pour water wherever there happens to be a fire. There's a lot of cool technical stuff about it, but somehow the water has to get into the building. And it comes from underground. This is a floor, and it comes up using an in-building riser. Usually those connect outside of the building, come underneath the foundation, and come up through the floor. That's called an in-building riser. And then there's a little stub. And on top of the in-building riser, there is a check assembly. Now, this one is not one that would be normally approved in California right now. It's a single check. Nowadays, they want us to use double checks in California. So we're going to replace this item with a double check. It means there's 2 check valves involved instead of just one, and it's more safe for the plumbing that goes on out in the street. Fire systems often have a lot of chemicals injected into them, fire retardants, and we want to make sure that under all circumstances that stays in the building and doesn't backflow into our potable water supply. So we're going to use a gate valve, double check valve, gate valve. Okay. After that, there's this thing called a fire department connection that hooks in so that the fire department can hook up a hose and start pumping into here from a hydrant. Okay, and that one does have a little single check valve that you can find online and draw. And then there's a little flow detector. And then this one's interesting. They kind of show it in a funny spot here. It's a main drain. Somehow you've got to be able to drain this fire system if you're going to do work on it. So you can put that main drain just as a T coming off anywhere after the check valve. Okay, so that's what's called a fire riser, and it protects the potable water from the fire system, but it also allows the fire department to push in to get extra water, especially if they don't have enough going on down here in the street and they need to really pump it in. And it keeps the kind of maybe contaminated with chemical water in the fire system from pushing back. So there's a simple fire riser. There's something called NFP, National Fire Protection Association, I think. NFPA 13, Standard 13. And so I did a lot of study of that in my working days in the field because our valves all had to meet that standard. So you should have some familiarity with NFPA 13, at least what it is and what it does, and a little bit about these things. Now, this is called a gate valve. They have it as a control valve. A gate valve is a particular type that you turn the handle and it pushes the gate down in here to turn it off. There's a tamper switch to make sure that it stays open and nobody accidentally turns it off. So if somebody starts screwing this thing in to turn this off, that sends an alarm to the fire department. It says, hey, somebody's turning off the fire system. Did you know that? And if they go, yeah, we knew that, it's an inspector, that's fine. But if they say no, then they send the police department out to figure out who's tampering with the switch. There's pressure gauges so that an inspector can see that everything is working properly from the point of view of the required pressure in the system. They're saying a standard check valve, and we're using a double check valve. There's some key connection. They have this water flow detector. The fire department wants to know when one of these things goes off. They have automatic little sprinkler valves that if they detect a fire, they start sprinkling. They don't wait for the fire department. And so these flow detectors detect if something has gone off and they send a signal to the fire department. So there we go. Those are the main parts of a fire riser. And your goal is going to be to model these. Model each of these parts and to create a standard, little semi-standard Revit in-building riser that you could put into a model. Okay, so kind of a cool thing. It's commonly done, and that's kind of the basis of what we're going to work on this week. Okay, so a little bit of research to back up what I've just told you, a little bit of modeling, create a Revit family, and then since you've got it, let's get some tabulated component drawings that you can include in your detailed drawings for your build out design.